Hello students, good evening all. So today we try to talk about kinematics and its basics. Okay, so what kinematics is? Kinematics is the branch of physics which deals with motion of bodies and their interactions with the surroundings without considering the cause of motion. So mainly broadly what we talk in terms of kinematics here. So in kinematics we talk about distance, displacement, okay, speed, types of speed, velocity, okay, acceleration. And when acceleration is uniform, okay, so how do you make use of the equations of motion? Okay, and if acceleration is not constant, that is called non-uniformly accelerated motion. So how we make use of the differential and calculus and integral calculus for solving the numericals of physics. And then we talk about graphs one by one sessions. Okay, yeah. Thank you. Next you see, so here we yes students, so now as we mentioned, kinematics is a branch of mechanics which deals with motion of bodies without considering cause of motion. Okay, so what is cause of motion here? Cause of motion is force. So in this chapter kinematics, so we won't talk about what you can call cause of motion, force we won't talk. Okay, only we talk about motion of bodies without considering the cause of forces. So generally if I have a particular body, for example, so without applying force, can the body move from one place to another place? It's not possible, right? So the cause of motion we are not going to talk here. So we only just talk about so how much displacement the body has undergone, or how much in straight line part or 1D motion you can talk about. Okay, so only how much distance the body has traveled, or how much amount of time the body has taken. Okay, time taken we can talk about, or you can talk about what kind of path the body is following. Okay, path followed by the particle, so you can talk here path followed. Okay, so like this kind of parameters we talk, but we won't talk about cause of the motion. So without cause of motion we talk about cause of motion is what here? Force. We won't talk about force, only we talk about how the body is moving. Okay, not why the body is moving. Clear? Right. The next we talk about first one here is displacement. So here displacement nothing but the shortest distance between initial point and final position. This is a vector quantity. So again we make separate video for vectors. What are vectors and all? Those physical quantities which have both magnitude as well as direction. What you should have? Both magnitude and direction. So those physical quantities which have both magnitude and direction are called vectors, and those have only magnitude, direction is not required, they are called what here? Scalars. So as you learn in your lower classes, all fundamental physical quantities, okay, so what are fundamental physical quantities? Can anyone? Yeah, fundamental physical quantities are those quantities which are defined what? Basically. So like we can come across here as length, mass, time, temperature, luminous intensity, amount of substance, okay, and electric current. So these quantities are basically defined as fundamental physical quantities. Okay, what are they? Length, mass, yes, time, temperature, intensity, amount of substance, electric current. So there's the fundamental base quantities we have defined. Okay, in SI units, you might be knowing their units also. Yes, length is measured in terms of meter, mass is measured in terms of kilogram, time is measured in terms of seconds, temperature is measured in terms of here Kelvin, and current is measured in terms of ampere. Okay, amount of substance is measured in terms of moles. Okay, electric current. Okay, intensity, I'm sorry, here current, no, electric current is ampere. So if you talk about intensity, intensity is in terms of candela. Okay, so you can make here what? Candela intensity. So here you can take electric current as ampere. Okay, so like this, so we can measure the fundamental physical quantities. All are scalars, only magnitude sufficient. Vectors are only those physical quantities which have both magnitude and direction. So like examples you can talk about coming classes: force, velocity, displacement, acceleration, momentum, etc. Currently remember. Okay, now coming for here now, so as you are talking, shortest distance between initial and final position is defined as what? Displacement. Now say for example a particle is at A, so you want to go it to B, so you can follow this path kind of from A to B like this, you can follow, or straight path you can follow, or you can follow this kind of path also. So among the given path which is the shortest path, okay, so always perpendicular distance becomes shortest. So here you can call AB bar is called here displacement. Okay, so now you can follow here AB bar displacement. So you can take one example also here. For example, a particle is moving along a circular path. Okay, so from A to B it is going. You can follow A to B along the curved path like this. You can follow, okay, while going from A to B, which is shortest one, along AB is shortest one, so R, so if you draw a straight line segment like AB bar, so this AB bar is the shortest path, okay, direct joining initial point to final point. Now for example A to B, now if you go from A to C for example, so you can follow A to C, it is a curved path now, which is longest path, and A to C is the shortest path. So here AC is the shortest path. So for A to B, this is for A to C. Now for A to B, AB bar is the shortest path. This is called displacement. Okay. Now if you consider here A to B, for example, this is R and this is R. So magnitude of the displacement becomes here now root 2R. Why students? R and R, Pythagoras theorem here, R square plus R square, which becomes root 2R. Now while A to C, if I consider A to C shortest distance, okay, displacement here you're calling, no? So R plus R, how much? That is called here 2R. Okay, this is what displacement is. Now the rate at which this displacement is covered, the rate at which this displacement is covered is called what? Velocity. Are following? So therefore we define here, so velocity vector v bar as the rate of change of displacement we call dx bar by dt bar, or you can also call delta x by delta t. This is called average. So total displacement by total time taken is called average, and this is called instantaneous. Okay, rate of change is called velocity. So you can know about its SI unit also. SI unit is given by meter per second. Okay, just brief revision I am doing this one for you for your exams. Okay, right, now coming for, so what is acceleration? So rate of change of velocity is called what here? Acceleration. Okay, so now here for example a body is going from one point to another point, for example, so starting from rest you can say, so acquired some velocity, say for example 5 meter per second after t is equal to 1 second. So next 1 second, say it has acquired a velocity of say 10 meter per second. Okay, so now you can say what is change in velocity in first 1 second? That is equal to 5 minus 0 by 1. This is meter per second by second. So we'll have unit will be meter per second square. Okay, next also, so delta v for next second, next 1 second also you can talk of same again, 10 minus 5 is 5 meter per second by second, you will get 5 meter per second. So this rate of change of velocity is called acceleration. So in this example, if you observe here, in first interval whatever the change in velocity, second interval change in velocity, so if you consider as a1 as a2, this a1 is equal to a2, this is what we call as uniform accelerated motion. So here if acceleration is constant, so we can make use of these equations of motion. So from basic definition of acceleration, so change in velocity by time, right? So this is v minus u by t. So if you consider this at is equal to v minus u, so v is equal to u plus at. Getting? This is what acceleration is. And definition from acceleration, we have found velocity after t seconds. Similarly, we can find out from average velocity definition, total displacement by total time taken, initial velocity plus final velocity by 2. So s becomes now u plus, you can write v value as here u plus at divided by 2 into t you can write. So this is u, so u into t, okay, plus u into t, that is 2 ut by 2, that is equal to ut plus half at into t is half at square. So you can find out the effective average displacement is given by ut plus half at square, the second equation. And you can also derive third equation here, v square minus u square is equal to 2as. The same fundamental we can derive here. You can eliminate t value, students, here. So s becomes now u plus v by 2 into t, you can write from this equation, from definition of acceleration, from this one, v minus u by a. So if you multiply, and we'll get 2as is equal to v square minus u square, like this. So as we are doing revision here, so how we are deriving third equation also. And we also, for solving problem displacement nth second also we can make use of, that is u plus a into n minus half in the nth second. Okay, so where g we are taking as 9.8 meter per second square. So same equation apply with a replace by g also for uniformly accelerated motion with bodies which are falling vertically downwards. So A is equal G, starting velocity is 0. You can write first equation as simply what? GT. Second equation you can write as what? Ut plus half gt square, but u is 0 here. Simply you can write half gt square, students. So from this you can take time taken to reach the ground, for example falling from certain height h. So t will be root 2h by z, right? From third equation, v square minus u square is equal to 2as 2gh. So velocity on reaching ground is equal to root 2gh. Clear? So like this we can derive this equation for bodies which are falling freely. Okay, and so here just recalling the graph here, velocity time graph. If acceleration is constant here, you can understand a is equal to v minus u by t, right? This is constant. So v minus u is equal to a into t, where a is constant here. So you can call here v and u are varying. So v is equal to u plus what you are saying 80. This is constant. This is equation y is equal to mx plus c. X plus c equation you can use. So on y-axis velocity you are taking, x-axis if you are taking time. So here velocity time graph for uniformly accelerated motion. If initial velocity is 0, you can take like this. If initial velocity is not 0, you will get the graph like this. Okay, so y is equal to mx plus c form. Okay, so y-intercept is here c we can take. So the slope, okay, slope what you will get here? Slope any instant of time you will get here slope. This is a change in value of y, change in value of x. So delta y by delta x we call slope. So change in velocity by time we call acceleration. Okay, now just you can have focus as a part of revision and numerical base. Body start from rest that means velocity is 0, and acceleration, write the numericals. So value 2 meter per second square. So start from rest now, find velocity after 5 seconds he is saying, velocity after 5 seconds. So you can use equation of motion, student. V is equal to u plus at, velocity after t seconds. So this v becomes u is 0, a becomes how much here? 2, and t is 5 seconds. So velocity becomes 10 meter per second velocity. And if you ask displacement for you, so if you ask displacement after t seconds, what is the formula? Ut plus half a t square. So starting from rest, this term becomes 0. So half a value is 2 given, and t square is 5 square. You can simply take beta 25 meters. Okay, as you can solve basic equations. Okay, and now as a practice you can take these questions, you can solve simultaneously along with me also. So velocity is given, acceleration and time. You can find direct formula. You can find out ut plus what? Half a t square. A ball is thrown upward with velocity. Find maximum height. See here, when a body is thrown vertically upwards with a velocity of 20 meter per second. Okay, so the maximum height means the velocity at which it becomes 0. That height is called maximum height. See students, as we know sign convention, when you are throwing upward, acceleration is here what? Downwards. You can say a is equal minus z. So third equation you can use, v square minus u square is equal to as. So velocity is 0 minus u square, 2 into a becomes minus g. That height is called maximum height. How much beta? Maximum height become now u square by 2z. Substitute the value here. So u value is given 20. So 20 into 20 by 2 into take g for a calculation, say for example 10. It goes 2 times. So this becomes maximum height is 20 meter. Now he's saying next question is draw velocity time graph for uniform motion. So here you can be more specified here. If velocity is constant also you can take, or acceleration constant. Uniform motion means here velocity if you take constant, draw velocity time graph for uniform motion. If velocity is constant, velocity is not in the function of time, this is the graph. If you mention acceleration is constant, you know velocity time graph is a straight line. If starting from rest, graph becomes like this as we have discussed. If not having some velocity, then the graph becomes like this. Okay, so you have to focus in this way as revision. Now what you have so far discussed, displacement change in position, rate of change of displacement is called velocity, the rate at which velocity changing is called acceleration, and we are using 3 equations of motion for solving the numericals. Okay, fine students, thank you all. Like this basic revision assignments I will be go on sending you. Okay, yeah, thank you all.